Hello everyone. In this video we'll see how to find out a term symbol, especially whenever an atom is given, the atomic term symbol, how to find out. And we'll also see one of the reasons why the street lights previously which were installed before LEDs, why were they yellow or orange in color. So the reason for that is, first of all we'll come back to the question. The question is, what is the term symbol for sodium? So directly they have not given the D configuration, or directly they have not given any configuration, directly they have given an atom. So how to find out the term symbol for sodium? First of all, let us write the electron configuration of sodium. 1s2, 2s2, 2p6 and 3s1. 1s2, 2s2 and 2p6, these are filled configurations. And for filled configurations, there are no spin angular momenta, orbital angular momenta. But for 3s1, there is one unpaired electron. So for that one unpaired electron, orbital angular momentum is absent because it is present in s orbital, whose h by 2 pi orbital angular momentum is 0. But it has got some spin angular momentum. So we can derive a term symbol for 3s1. Now let us derive the term symbol for 3s1. Since the orbital angular momentum value is 0, the total orbital angular momentum also becomes 0. Spin of one electron is 1 by 2, which becomes the total spin, which is also 1 by 2. 2s plus 1 L, this is the term symbol, where 2s plus 1 is the spin multiplicity and L is the orbital angular momentum. Total orbital angular momentum. This is total orbital angular momentum. If I want to get the states, we can also take J, where J is total angular momentum. That is to find out the states. Now let us find out. We have L is equal to 0. So when L equal to 0, 1, 2, 3, 4, we have values of S, P, D, F, G and so on. So for 0, the symbol is uppercase S or capital S. Spin multiplicity, the total spin is 1 by 2, so 2s plus 1 equals 2 into half plus 1, doublet. So we have doublet S. This is the term symbol for sodium, okay, in the ground state. But this is only doublet S. This is not a state. Suppose if I want to know the state, it is J. So J takes up L plus S up till L minus S values. L anyway it is 0. S is 1 by 2. So the state is doublet S 1 by 2. This is for sodium ground state. Okay, remember the term symbol. Suppose that I start heating the sodium. When I start heating the sodium, the configuration will be 1s2, 2s2, 2p6. Electron from 3s will move into 3p. So 3s electron is now slowly moving to 3p. 3s is vacant, whereas 3p is now occupied by a single or an unpaired electron. So now it is taken as a p1 configuration. For p1 configuration, any electron present in p orbital has an orbital angular momentum of 1. So the total orbital angular momentum also becomes 1. Spin of one electron is 1 by 2. Therefore, the total spin also becomes 1 by 2. Then we have L equal to 1 and S equal to 1 by 2. Just now we have seen when L equal to 1, the term symbol will be P. Spin multiplicity 2s plus 1. So 2 into 1 by 2 plus 1, it will be doublet P. And then we have J values L plus S up till L minus S. So 1 plus 1 by 2, 1 minus 1 by 2, we have doublet P 1 by 2, comma, doublet P 3 by 2. These are the term symbols for sodium in the excited state. Now let us look at the transitions. Why the street lights, they used to be yellow orange in color. Presently they are anyway replaced by LED lights, but previously we used to have sodium vapor lamps. So sodium present in the ground state, just now we have seen that the energy level was represented by doublet S 1 by 2, and sodium in the excited state we have two energy levels which were very close because they belong to doublet P 1 by 2, doublet P 3 by 2. So let us go for the transitions. From the ground state there is one transition and also there is a second transition. These two transitions are very close. One is at 5890 angstrom because it is a higher energy one, and a lower energy one 5896 angstroms. They are very close and almost they overlap one another, therefore we get almost a doublet type of a peak. So we call it as sodium D line. Even in the polarimeters we will be using this sodium D line, where this D represents doublet, sodium doublet. And this excitation is the reason for the yellow orange color. So for the question that has been asked, what is the term symbol for a given atom? First write down the electron configuration. Once you have written the electron configuration, look for the unpaired electron configuration. For those unpaired electrons, find the L value, find the S value. To get the states, also find the J values. And in the case of sodium, which we used to use in the street lights, the yellow orange colored ones, the ground state, it was having a term symbol or a energy level of doublet S 1 by 2, and the excited state is doublet P 1 by 2 and doublet P 3 by 2. Two transitions are possible which are very close to one another and they almost overlap, therefore we call it as a sodium D line. Thank you.